So how do we work out the bending moment of a cantilever? So let's take an example here. What I have here, I've got a beam which is cantilevered into the wall. So there's that fairy thing says that that's the wall and that's solid. Out of here I have several forces acting. I've got 20 here at 1.5 metre, I've got a 40 acting at 3 metres, I've got 10 acting at 4 metres, and I've also got a support under this part here acting of 20 acting at 2 metres. So what we're going to do is we do it the normal way if we want to find out the maximum bending moment. So we draw our free body diagram. So we have our beam hanging out here. I'm just going to put, so I've got 20 acting here at 1.5. I've got 20 acting up at 2. At 3 I've got 40 acting down, and that's at 3, and at 4 I've got 10 acting down. Now we don't have to work out the supports or anything like that, so this is our, and there's going to be a force acting here, and there's also going to be a fixing moment acting that way. So if this is going down, this fixing moment will act in the opposite direction to the moments applied here. So let's actually work this all out. So what we're going to do, first things first, we draw the free body diagram. Then I'm going to put my lines on, my working lines on, of where the forces are acting. Like that. And I'm going to do my shear force diagram. So my shear force diagram, one of the big differences with a cantilever is we don't know what the force here is. In fact, that's what we've got to work out. So when we're doing this, we have to start at the free end, whichever end's the free end. So this is the free end, this is the bit that's hanging out. So we're going to go backwards. So the first thing that happens is this drops down 10. So we're going backwards, so we've got a force of 10 going down. We go along. It drops down another 40. It goes along here. There's a force that goes, 10, so that's going to be 50. We drop 10, we drop another 40, that's 50. We then go up 20, so we go back up to 30. We drop down 20 again, back to 50. And then we're going to go along at 50. And this is going to be our reaction force, or our fixing force. At this point here, we must have a fixing force of 50 kilonewtons. If we've got 50 acting down, there must be 50 acting up here, so this goes up 50. And then what we do, hopefully there's enough room on here, we're going to draw in our bending moment, and I'm going to put the axis here. So this is the bend, so this is the shear force, this is the bending moment diagram. And now it doesn't really matter which end we start at, but we're going to start at the free end again. So we're going to break this up into various areas, 1, 2, 3, 4, because we've got to find out what the fixing moment is. So we've got a bending moment, so we've got a fixing force. This is the force upwards that's applied by the wall. And let's just check. We've got 50 here, we've got 20 here, so we've got 70 acting up. We've got 20, 40, 10 down there, that's 70 acting down, so that's right. So what we do, again, we start at the free end. Area 1 equals 10 by 1 equals, well, it's going to be negative 10 because it's under the line. Negative 10 equals negative 10. So we're going to go from here down to negative 10. We go area 2 now is really big. It equals 30 times 1 equals, well, it's negative 30 times 1, that's negative 30. So we're going to add in, we're going to end up at negative 10 plus negative 30 is negative 40. We're going to end up at negative 40. Notice that the slope should be different. We then go back a bit. Area 3 is equal to negative, that's negative 50, isn't it? That's negative 50, sorry, that's negative 60. Ooh, my bad. This area here is equal to negative 30 times 0.5, which is equal to negative 15. So on the negative 60, we add another negative 15, so that's negative, sorry, that should be shallow, negative 75. Then here we've got 50, area 4 is equal to negative 50 times 1.5, which is equal to negative 75. And that means we're already at negative 75, so we end up with negative 150. And that's going to be our fixing moment. So the fixing moment, if this beam is bending this way, this has to go the other way. So this is going to be counterclockwise, and the fixing moment is therefore going to be 150 kilonewton meters. And if we look at what that beam's doing, you'll notice that the beam's just sagging and sagging and sagging. Yeah. Okay, so maximum, yeah. So basically what we can tell looking at this, the difference between a simply supported beam, just start at either end is going to be 0. With a cantilever, you start at the free end. The free end, everything's going to be 0. And then you work in from the free end to the wall. And then the wall, when this size here, that is going to have, the wall is going to supply a force to make that equal to 0, so that lets us work out what the wall is. And the wall is also going to supply a fixing moment, and we can figure that out by how far up or down that goes. And this is one of the reasons for actually working out bending moment diagrams. This lets us work out cantilevers, road signs, all sorts of things. So next video we're going to be doing an example using a UDL, a uniformly distributed load, and this could be the weight of the beam itself or anything else like that.